Okay, last but not least, we have CV data. What is our CV data telling us? Well, whereas our UV-Vis data is telling us things like the distance between the orbitals that are occupied and unoccupied in our test complex, our D6 iron 2. And our magnetic susceptibility data, our Evans method data, is telling us how many unpaired electrons we might have. CV is an interesting thing because what we're looking at there is we have our complex X, and we are seeing it either lose or gain an electron. So that's our reduction event, gains an electron. Losing an electron is going to be our oxidation event, going to either X plus or X minus. What this is telling us then is the relative energies of the pairs, the paired and the unpaired electrons. How easy is it to put an electron in or take an electron out? And so CV is only useful in comparison with other data. It doesn't tell us anything by itself, right? We'll get a value with respect to the ferrocene-ferrocenium couple, but on its own, we don't get a lot of information that helps us know anything about the complex, but we can then learn something about how that's going to react with other types of complexes, other types of reactants. Is it easy to oxidize? Is it easy to reduce? That might make it a good catalyst for some reduction or oxidation reaction. It depends. And so we always want to refer to some reference point. In this case, our reference point is that ferrocene-ferrocenium couple, right? Using our standard of ferrocene, which is a relatively easy to oxidize compound, and it is very reversible, very well behaved in solution. We can use that as kind of a standard to tell us this is easier to oxidize than ferrocene. This is harder to oxidize than ferrocene. And that way we'll know how easy it is and relatively how much more potential or less potential we have to put in to make that transformation happen.